everyone, in this video I'm going to discuss the example for limits. Kindly refers to the question. Limit when x approaching 3. For the function we have the x squared minus 8x plus with the 15 over the x minus 3. So if we substitute the value 3, and we will have 9 minus 24 plus with the 15, and we will obtain 0 over 0, where we call it indeterminate form. The suggested strategy would be multiply by the conjugate, factorize the situation, or long division. So in here, my suggestion would be factorize the situation. Limit when x approaching 3. If we factor the x squared minus 8x plus with the 15, and we will have x minus the 5, x minus the 3, over we have x minus 3. Notice that we have a common terms, so we can simplify the situation given. So rewrite the situation. So limit when x approaching 3, then bracket we have x minus the 5. So if we substitute the value 3, and we will have the value y approaching negative 2. Next, we have the situation. Limit when x approaching negative infinity. For the function, we have x squared plus 1 over the x cubed minus 2. If we substitute the value, and we will have positive infinity over the negative infinity, where we have the indeterminate form. The strategy will be dividing the highest power of the denominator. Highly refers to the numerator and also the denominator, and the highest power for the denominator will be x to the power of 3. So in here, my suggestion would be factor out the x to the power of 3. So if we factor out the x to the power of 3, then we will have 1 over the x, plus we have 1 over x to the power of 3, over, factor out the x to the power of 3, so we will have 1 minus 2 over x to the power of 3. So if we simplify, limit when x approaching negative infinity, we have 1 over x plus with 1 over x to the power of 3 over 1 minus 2 over x to the power of 3. So if we substitute, then we will obtain 0 over here, 0 over here, 0 over here. So finally, limit when x approaching negative infinity, x squared plus with the 1 over x to the power of 3 minus with the 2, then we will have 0 over 1, the value of y will be approaching 0. So this one we can call it horizontal asymptote, y is equals to 0 as well. Kindly refers to C. Limit when x approaching 1 from the left. For the function, we have the modulus 1 minus x over the 3x squared minus 4x plus with the 1. First of all, define the situation. We have modulus 1 minus x. Based on the definition, we have 1 minus x, negative bracket 1 minus x. With the domain x less than and equals to 1, x greater than 1. So that is the definition. So in here we have a number line. For the left hand side we have 1 minus the x, included the 1 as well. And then for the right hand side, x greater than 1, we have negative bracket 1 minus x. So that is the definition. Limit when x approaching 1 from the left. So here we have the left hand side, 1 minus the x over, if we factor the situation, so here we will have 3x minus 1 multiplied with x minus 1. Rewrite the situation. Limit when x approaching 1 from the left, factor out the negative, and we have x minus 1 over, we have 3x minus 1, x minus 1. Simplify the situation. Limit when x approaching 1 from the left, we have negative 1 over 3x minus 1. So if we substitute the value, limit when x approaching 1 from the left, for the function modulus 1 minus x over, we have 3x squared minus 4x plus with the 1. The value of y will be approaching, if we substitute 1, we will have 3 minus 1, which is equals to negative 1 over 2. The value of y will be approaching negative 1 over 2. Hello everyone, in this video I'm going to discuss the example for differentiation. Given we have the piecewise function fx. Determine the fx is differentiable at x is equals to 3. So notice that we have the modulus, so kindly define the modulus. So here we have modulus 3 minus x. So we have 3 minus x, we have negative bracket 3 minus x based on the definition, and we have the domain x less than equals to 3, x greater than 3. So that is the definition. Based on the 3, for the left hand side, we have 3 minus x. For the right hand side, we have negative bracket 3 minus x. For the equals to 3, we have the left hand side. So next, illustrate the situation in a real number line. Here we have the 3. If x is equals to 3, we have the negative 7. If x greater than 3, we have 2x minus the 13. If x is less than 3, so here we have x plus with the 4 multiply with x minus the 3 over we have 3 minus the x. So based on the function given. So refers to the question, determine whether the fx is differentiable at x is equals to 3. So the formula would be limit when x approaching a for the function fx minus the fa over x minus a. So in here, focus is the a is equals to 3. So limit when x approaching 3 from the left. Refers to the function, we have x plus with the 4 multiply with x minus the 3 over the 3 minus the x. So here we have the function fx minus the fa. So in here we have 3, the value will be positive 7 over we have x minus the 3. So we write the situation, limit when x approaching 3 from the left. If we factor out the negative, so we have x plus with the 4 bracket, we have 3 minus the x over 3 minus the x plus with the 7 over x minus the 3. Notice that we have the common terms. So we can simplify the situation. Limit when x approaching 3 from the left. If we simplify, we have negative x, negative 4 plus with the 7 over x minus the 3. Limit when x approaching 3 from the left. If we factor out the negative, so we will have x and then minus the 3 over x minus the 3. So the value of y will be approaching negative 1. So that is the f prime 3 from the left, which is equals to negative 1. Focus on the right hand side. Limit when x approaching 3 from the right. For the function, we have 2x minus the 13 minus. If it refers to 3, we will have positive 7 over x minus the 3. Limit when x approaching 3 from the right, we have 2x minus become plus with the 7, so we have negative 6. Rewrite the situation, limit when x approaching 3 from the right, so factor out the 2 and we have x minus 3 over x minus the 3. So the value of y will be approaching 2. So f prime bracket 3 from the right, so here we have the 2. Since the f prime 3 from the left is not equals to f prime 3 from the right, so we can say f prime 3 does not exist. Then fx is not differentiable at x is equals to 3. Kindly refers to b. Differentiate the situation y is equals to ln bracket, we have x multiplied with the surd 1 plus with the x squared. By using the law of log, so here we have ln mn, which is equals to ln m plus with the ln n. So y will be equals to ln x plus we have ln square root. Square root, here we have 1 over 2 ln bracket 1 plus x squared. Differentiate the situation, dy dx equals to 1 over x bracket 1 plus 1 over 2 bracket 1 over 1 plus x squared. Differentiate the internal function, so we have 2x. So dy dx equals to 1 over x plus we have x over 1 plus with the x squared. So kindly equate the denominator. So dy dx, which is equals to 1 plus with the x squared plus with the x squared over we have x multiply 1 plus with the x squared. So finally the dy dx, which is equals to 1 plus with the 2x squared over we have the x bracket 1 plus with the x squared. So that is the first derivative. Hello everyone, in this video I'm going to discuss the example for application of differentiation regarding the rate of change. Kindly refers to the question, in a sample physical apparatus, the distance x and y are related to the equation where we have 1 over x plus 1 over y equals to 1 over 5. If the y is increasing at the rate, so automatically we have dy dt equals to 16 cm, then we have the minute. Calculate the rate at which the dx dt when the y is equals to 9. So now my suggestion would be find the x first before we start the situation given. So let's say y is equals to 9. If we substitute, we have 1 over x, which is equals to 1 over 5 minus 1 over 9. So now we have 9 minus the 5 over 45. So 1 over x, where we have 4 over 45. Then in order to find the x, so we have 45 over the 4. So that is the situation given. Continue. Next, we have the chain rule. Focus on the chain rule. We have dx dt equals to dy dt, which is given, multiply with the situation dx dy in order to obtain the dx dt. Continue. So now focus on finding the dy dx. So here we have 1 over x plus 1 over y equals to 1 over 5. If we differentiate the 1 over x with respect to x, so here we will have negative 1 over x squared. Minus, if we differentiate the 1 over y with respect to x, so here we have negative 1 over y squared. You remember, add on the dy and dx equals to 0. Try to rearrange the situation. We have the dy dx, which is equals to, so here we have 1 over x squared. If we rearrange, then do remember multiply. So we have negative y squared. So the dy dx is negative y squared over the x squared. So do remember to flip the situation. So dx dt, which is equals to, we have 16 bracket, so negative, we have the x squared over the y squared. So if the value of y, which is equals to 9, the value of x, where we have 45 over 4, by referring to the calculator, so we will have the dx dt negative 16, we have the x squared, which is the 45 over 4 bracket square over the 81. So the dx dt, where we have negative 25. So here we have the cm and then minute negative 1. So x is decreasing at the rate 25 cm per minute. Hello everyone, in this video I'm going to discuss the example for complex number. Kindly refers to the question, given we have 2 plus with the ai equals to, we have the fraction complex number, sec 2i over b plus with the I. Find the value a and b. So my suggestion would be cross multiply the situation. 2 plus with the ai multiply with the bi equals to 6 minus 2i. Kindly expand the situation. We have the 2b plus with the 2i and then plus with the a, b, I minus the a, which is equals to 6 minus 2i. Compare the real part and also the imaginary part. So we have 2b minus a, which is equals to 6. So we have 2 plus with the ab, which is equals to negative 2. ab, which is equals to negative 4. Next, a is equals to, we have 2b minus the 6. If we substitute the situation, so here we have 2b minus the 6 bracket, then multiply with the b equals to negative 4. If we expand, 2b squared minus 6b plus with the 4 equals to 0. Kindly factor out the situation. We have b squared minus the 3b plus with the 2 equals to 0. Factor the situation. We have b minus 2, b minus 1 equals to 0. So b is equals to 2, b is equals to 1. If the b is equals to 2, b is equals to 1, so the value of a will be equals to negative 2. If is a 1, the value of a will be equals to negative 4. Hello everyone, in this video I'm going to discuss the example for equation, inequalities and absolute inequalities. Kindly refers to the question, solve the equation given. Based on the question, notice that we have the same base, which is 3 to the power of x. So here we have 2 bracket 3 to the power of x bracket square multiply with 3 to the power of 1 plus 7 Multiply 3 to the power of x minus 3, which is equals to 0. Let y is equals to 3 to the power of x. So in here, we have 6y squared. Plus with the 7y minus with the 3 equals to 0. Kindly factor out the situation. We have 3x minus 1 and then 2x plus with the 3, which is equals to 0. So x will be equals to 1 over 3, where we have x, which is equals to the 3 to the power of x equals to 3 to the power negative 1. So x will be equals to negative 1. So another one, we have x is equals to negative 3 over the 2. So 3 to the power of x equals to negative 3 over the 2. If we log both sides, we notice that for the right hand side, which is invalid. So we can say x minus 1 satisfies the equation given. Kindly refers to B. We have the inequalities. First, we have to equate the denominator. So 2x minus 1 minus the 3 multiplied with x minus 3 over, we have the x minus 3 greater equals to 0. 2x minus 3x minus 1 plus with the 9 over, we have x minus 3 greater equals to 0. Negative x plus with the 8 over x minus 3 greater equals to 0. Notice that this is the simplest form. So we can determine the sign, which is the positive sign. Next, assume always positive. So negative x plus with the 8 greater equals to 0. X minus the 3 greater than 0. So x is less than equals to 8 and x is greater than 3. Kindly illustrate the situation in the real number line. We have the 3 and also the 8. X greater than the 3. X less than and equals to 8. So here we have negative, negative. So negative, positive, negative. We are interested in the positive. So the interval will be start from 3 until 8, where the 3 is not included. Kindly refers to C. Solve the situation given. So my suggestion would be square both sides. So if we square both sides, we will have x plus 2 bracket square less than equals to, we have 4 bracket x plus minus 3 bracket with the square. Next, expand the situation. We have x squared plus with the 4x plus with the 4 less than and equals to, we have 4 bracket x squared minus the 6x and then plus with the 9. So we have 4x squared minus 24x plus with the 36. So rewrite the situation. We have 4x squared minus the 24x plus with the 36 minus the x squared minus the 4x minus the 4 greater equals to 0. So 3x squared and then minus the 28x and then plus with the 32 greater and equals to 0. Factorize the situation. We have x minus the 8, 3x minus the 4 greater equals to 0. Since this is the simplest form, we have to determine the sign where we have the positive sign. Next, assume always positive. X greater equals to 8, x is greater equals to 4 over 3. Illustrate the situation in the real number line. We have 4 over 3 and then also the 8. Then circle towards the right, then circle towards the right. So here we have positive, negative and positive. We are interested in the positive. So the answer would be negative infinity until 4 over 3. Union, start from 8 until infinity. So these inequalities satisfy the absolute value inequalities. Hello everyone, in this video I'm going to discuss the example for function and graph. Given we have the f bracket 3 minus 2x, which is equals to x over x minus 2. Find the fx. State the domain and range for the situation given. So if it refers to the situation, actually this is a composite function. So let this one s become y. Then express the x as a subject. So we have 2x, which is equals to 3 minus the y, x, which is equals to 3 minus the y over the 2. So kindly substitute the situation. So f bracket y, which is equals to, now what we have to do is to change the term from x to y, because we have fy. So kindly substitute the x, where we have 3 minus y over the 2 over, we have 3 minus the y over the 2 minus the 2. Kindly equate the denominator. So we have fy, which is equals to 3 minus the y over the 2 over, we have 3 minus the y and then minus the 4 over the 2. Rewrite the situation. 3 minus the y over the 2 bracket, we have 2 over, we have negative y and then minus 1. So kindly simplify the situation. We have the fy, which is equals to 3 minus the y over, we have the negative bracket, y plus the 1. So find the fx. So fx, where we will have y minus the 3, it become x. So x minus the 3 over, we have x plus with the 1. So refers to the situation, find the domain for the f. So negative infinity until negative 1 union, negative 1 until infinity. So that will be the domain for the f. At the same time, actually it is the range for the f inverse. Next, in order to find the range, what we have to do is to refer to the c, referring to the inverse later on. So let's focus on the b. So kindly focus on the b. Show that fx is one-to-one function by using the algebraic approach. So here we have the x sub 1, which is equals to x sub 2. So kindly substitute. We have x sub 1 minus the 3 over the x sub 1 plus with the 1 equals to x sub 2 minus with the 3 over the x sub 2 plus with the 1. Kindly cross multiply the situation. So x sub 1 minus the 3 multiply with x sub 2 plus with the 1 equals to x sub 2 minus the 3 multiply with the x sub 1 plus with the 1. Kindly expand. X sub 1, x sub 2 minus, we have the plus x sub 1 minus the 3x sub 2 and then minus the 3. So x sub 1, x sub 2 plus x sub 2 minus 3x sub 1 and then minus the 3. Notice that we have the same element in here, so we will have 0. Same element for this part, again we will have 0. So at the end, the simplest form would be x sub 1 minus 3x sub 2 equals to x sub 2 minus 3x sub 1. So kindly rearrange the situation. So in here we will have x sub 1 plus with the 3x sub 1 equals to x sub 2 plus with the 3x sub 2. So 4x sub 1 equals to 4x sub 2. So x sub 1 equals to x sub 2. Shows that fx is 1-to-1 function. Kindly refers to C. Find the f inverse. Do you remember the statement y equals to fx? So f inverse of y, which is equals to x. So kindly substitute. Y is equals to x minus the 3 over x plus the 1. So we have y multiplied with x plus 1, x minus 3. xy plus the y equals to x minus the 3. Kindly rearrange the situation. X bracket y minus the 1 equals to negative 3 minus the y. So x is equals to a negative bracket 3 minus the y become plus the y over y minus the 1. So f inverse of the x will be equals to 3 plus with the x over 1 minus the x. So that is the f inverse. So the domain for the f inverse would be negative infinity until 1 union 1 until infinity. So here we have the range for the f. So that is the answer for question 8. So the range for the f would be negative infinity until 1 union 1 until infinity. Hello everyone, in this video I'm going to discuss the example for function and graph. So given we have the function gx, which is the ln, and also the hx, which is the exponent. A, find the g rho h and then h rho g. So let's focus on g rho h. So in here they mentions that we have the g and then the rho for the h. So 3 exponent negative x over the 2. Kindly substitute the situation into the g. So where we have 2 ln bracket 3 over 3 exponent negative x over the 2. So if we simplify 2 ln bracket, we have the exponent x over the 2. So if we simplify ln and e, then we will have 2 bracket x over the 2. So finally g rho h, where we will have x. Continue. We have h rho g. So h bracket g. So we have 2 ln 3 over the x. So if we substitute the h, then we will have 3e negative. We have 2 ln 3 over the x over the 2. So if we simplify, we will have 3 exponent. We have the ln bracket 3 over the x to the power of negative 1. So if we simplify, we have 3 bracket 3 over x to the power of negative 1. So meaning that we have 3 bracket x over the 3. So h rho g, where we have x. So since we have g rho h, which is equals to h rho g and equals to x, then we can say that g and the h are inverse to each other. Kindly refers to B. Sketch on the same coordinate axis graph for the function gx and so the hx. So I prefer to start with the hx. So hx, which is equals to 3 exponent negative x over the 2. So number 1 kindly refers to the xy axis. So basically refers to the hx, and we notice that we have y equals to 0 as a horizontal asymptote. Then if we substitute when x is equals to 0, then we notice that we have 3 exponent 0, which is equals to 3. So here we have 1, 2, and 3. So the y-intercept will be 0 and 3. So the graph will be something like this. So that is the graph for the hx. So continue. Next, we have the situation given, which is y is equals to the x. Where is the reflection axis? So as for the example, if we flip the situation, then we will have 1, 2, and 3. So the coordinate will be 3, 0 for the x-intercept. Next, we have x is equals to 0 because we have y equals to 0. If we reflect, we have x equals to 0. Continue. If this part, we have the negative x and then positive y. So if we reflect, we will have positive x and then negative y. So let's say over here. As for this part, we have the positive x and also the positive y. So the situation would be around here. So the graph will be something like this. So that is the graph for the gx. So do remember, make sure you have label the x and y axis, and then the vertical and horizontal asymptote, then the points of intersect for y-axis, and also the reflection axis. Kindly refers to C. Question asks us to find the h square rho g, and then we have the value 2. So we can assume something like this: h rho g 2. So based on the situation given, we have h rho g, which is equals to x. So for this case, h rho g, which is equals to x. If h rho g 2, automatic x will become 2 as well. So kindly substitute the situation into the h. So 3 to the power of e to the power of negative. So we have 2 over the 2. So we will have 3e negative 1 or 3 over e. So that is the h squared g bracket 2. Hello everyone, in this video, I'm going to discuss the example for limits and continuity. Kindly refers to the question, find the value h for the situation given. So limit when x approaching h for the situation x minus the 9 over, we have 3 minus the third x, which is equals to 6. So based on the situation given, we can substitute the h. So here we will have h minus the 9 over 3 minus the third h, which is equals to 6. Next, multiply by the conjugate, h minus the 9 over 3 minus the third h bracket 3 plus with the third h over 3 plus with the third h, which is equals to 6. So h minus the 9 multiply with 3 plus with the third h over, we have the 9 minus the h, which is equals to 6. So factor out the negative. So here we will have negative bracket 9 minus the h, bracket 3 plus with the third h over 9 minus the h. So if we simplify, then we will have 3 plus with the third h, which is equals to negative 6. So third h, which is equals to negative 9. Square both sides. Then the h will be equals to 81. Kindly refers to B. Given the function, we have the piecewise function. So kindly illustrate the situation in a real number line where we have negative 3 and also the 1. So based on the situation given, here we will have 5x plus with the 2. Continue, we have 7x to the power of 3. So that is the situation. Determine whether the fx is continuous at x is equals to 1. Step number 1, f bracket 1, which is equals to this part, we have the 7. Step number 2, determine the limit whether exists or not. So approaching 1 from the left for the function 5x plus with the 2, if we substitute, we will have 7. Limit when x approaching 1 from the right, 7, x to the power 3, and we will have 7. Limit when x approaching 1 from the left for the function fx is equals to limit when x approaching 1 from the right for the function fx. So the limit exists. So limit when x approaching 1 for the function fx, the value of y will be approaching 7. So consider limit exists. Step number 3, f1, is it equals to limit when x approaching 1 for the function fx? The answer is yes. So if it's a yes, so fx is continuous at x is equals to 1. Hello everyone, in this video I'm going to discuss the example for limits and also the asymptote. Given we have the function, so where we have the gx. Find the limits at the appropriate value, obtain the horizontal and the vertical asymptote if exists, hence sketch the graph. So step number 1, find the domain. If we refer to this part, we notice that we will have all real number. Continue, refers to the denominator, and we notice that 2x plus with the 3 cannot be equals to 0. So x cannot be equals to negative 3 over 2. So domain for the g, we will have negative infinity until negative 3 over 2, union negative 3 over 2, infinity. So that is the situation given. So given the function, we have the gx, where we have square root of 4x squared plus with the 1 over, we have the 2x plus with the 3. Next is to find the xy intercept. For the x-intercept, when y is equals to 0. So if we substitute 0, and we notice that the square root of 4x squared minus a plus with the 1, which is equals to 0. If we square both sides, so we will have 4x squared plus with the 1 equals to 0. 4x squared, which is equals to negative 1. X squared, where we have negative 1 over 4. So x will be square root of negative 1 over 4. So for this case, the situation does not exist. Next, find the y-intercept when x is equals to 0. So if we substitute the situation, and we notice that we have y, which is equals to 1 over 3. So here we have the coordinate 0, 1 over 3. Next, step number 3. Limit when x approaching, we have 3 over the 2. From the left, for the function, we have square root 4x squared plus the 1 over, we have 2x plus the 3. Limit when x approaching negative 3 over the 2 from the right, we have the square root 4x squared plus the 1 over 2x plus the 3. By referring to the calculator, and we notice that we have the negative infinity, which means that when x approaching negative 3 over 2 from the left, the graph will be decreasing. Whereas for the situation on the right, when the x approaching 3 over 2, negative 3 over 2 from the right, the value of y will be increasing. So from here, vertical asymptote. So x will be equals to negative 3 over 2. Step number 4 is to find the horizontal asymptote. Limit when x approaching negative infinity. So here we have the square root 4x squared plus the 1 over 2x plus with the 3. Factor out the x. So from here we have the x square. Then here we have 4 plus with 1 over the x square over, we have x, 2 plus with the 3 over the x. Based on these part, the square root of x square will be negative. So limit when x approaching negative infinity, we have negative x square root 4 plus with 1 over x square over, we have the x bracket 2 plus with 3 over the x. Limit when x approaching negative infinity, we will have negative square root 4 plus with 1 over x square over 2 plus with 3 over the x. So if we substitute the situation, here we will have 0, here we will have 0, so we will have negative 1. Continue. Limit when x approaching positive infinity. For this part, it will be a positive x. So here we have square root 4 plus with the 1 over x square over, we have 2 plus with 3 over the x. So the value of y will be approaching 1. So horizontal asymptote, y is equals to negative 1, y is equals to 1. So kindly refers to the graph. So first, kindly refer to the number 1. We had the asymptote. So let's say here 1, here 2. So the asymptote will be around here, where we have x, which is equals to negative 3 over the 2. Next, here does not exist, and then so here we have the situation 0, 1 over 3. So let's say 0 over here, and then 1 over 3 around here. So name it 0, 1 over the 3. Continue. When x approaching the negative 3 over 2 from the left, the graph will be decreasing. Whereas from the right, we will have increasing. Then the vertical asymptote is written. Continue. When x approaching negative infinity, we will have the situation y, which is equals to negative 1, which is the horizontal asymptote. Another one, we have the situation y, which is equals to 1, as the x move on to the right hand side or positive infinity. By referring to the calculator, if we substitute x is equals to negative 50, and we notice that we have the value which is lower than the negative 1. If we substitute x, which is equals to 50, and then the value of y would be less than 1. So the graph will be something like this. So that is the graph for the gx, and then here we have the y-intercept, horizontal asymptote, and also the vertical asymptote. Hello everyone, in this video I'm going to discuss the example for differentiation. Kindly refers to the question A. Use the definition given, we have the f prime A. Find the f prime A if exists, where given the value of A which is equals to 6. So refers to the situation by referring to the number line, we have x less than equals to 6, where we have 6 square root x plus with the 3. X greater than 6, where we have x plus with the 12. By referring to the situation, limit when x approaching 6 from the left. So we have the fx from the left, 6, multiply with x plus with the 3, minus the fa. So we have to substitute 6 plus with the 3, 9, square root of 3, square root of 9, then we have 3. So we have negative 18 over, we have x minus the 6. So try to simplify the situation. So limit when x approaching 6 from the left, factor out the 6, then we will have square root of x plus with the 3 minus the 3 over, we have x minus the 6. Multiply by the conjugate, we have sert x plus with the 3 plus with the 3 over sert x plus with the 3 plus with the 3. So if we expand, then we will have limit when x approaching 6 from the left. So we have 6 bracket. So making use of the formula, we have x plus with the 3 minus the 9 over, we have x minus the 6. Multiply with the square root x plus with the 3 plus with the 3. So limit when x approaching 6 from the left. So 6 bracket, we have x minus the 6 over, we have x minus the 6 bracket, square root of x plus with the 3 plus with the 3. So notice that we have the common terms. So we can simplify And rewrite the situation. Limit when x approaching 6 from the left, we have 6 over the square root of x plus with the 3 plus with the 3. So based on the situation given, so we will have 1. So f prime bracket 6 from the left, we will have 1. Continue on the right hand side. Limit when x approaching 6 from the right, refers to the function we have x plus with the 12 minus the 18 over x minus the 6. Limit when x approaching 6 from the right, we have x minus the 6 over x minus the 6, where we have 1. So f prime bracket 6 from the right, we will have the value 1. So f prime 6 from the left equals to f prime 6 from the right are the same. So we can say f prime bracket 6, which is equals to 1, exists. Kindly refers to B. Given the situation where we have y squared equals to 2xy plus the 2x. So question asks us to prove the situation given. So let's differentiate with respect to x. So here we have the 2y dy dx equals to, we have the product rule. So 2 bracket y differentiate the x and we have 1 plus, we have the x differentiate the y, then we will have dy dx. And then plus we have the 2. So kindly rewrite the situation given. So we have the 2y, then we have the y prime equals to 2y plus with the 2x, then we have the y prime, and then plus with the 2. So notice that we can simplify all the 2, so it becomes y multiplied with the y prime, and then continue equals to y plus with the 2. We have x and then y prime and then plus with the 1. Rewrite the situation. They have the y prime bracket, we have the y minus the x, where we have y plus with the 1. So next what we have to do is to differentiate for the second time. So if we differentiate for the second time, what we have to do is we have y minus the x, and then we have differentiate y double prime. Plus we have the y prime. Then if we differentiate, we have differentiate the y, so it becomes y prime and then minus the 1. So that is the product rule, equals to, we have the y prime and then 0. So kindly refers to the question above, and we notice that we already have the shape. So for example, so in here we have x minus the y. So here we have negative, then here we have y double prime. Continue. Here we will have plus, we have the y prime bracket square, minus, we have the y prime and then minus the y prime equals to 0. So try to rewrite the situation given. We have the x minus the y bracket double prime. So continue. Here we will have plus 2y prime, and then minus, we have the y prime bracket square, which is equals to 0. So kindly rewrite the situation given. X minus the y bracket, we have the second derivative, plus with the 2 dy dx, minus bracket, we have the dy dx square, which is equals to 0. So continue. We already shown the situation. Hence find the value for the second derivative given that y which is equals to 1. So if y which is equals to 1, so we have to find the value of x. So where we have 1 equals to 2x plus with the 2x, then we can say we have x which is equals to 1 over 4. Continue. Next, in order to find the first derivative, the value for the first derivative, we must know that y which is equals to 1, x which is equals to 1 over 4. Then we will have the situation y prime bracket. So we have 1 minus 1 over 4, where we will have 3 over 4. And then equals to, we have the 1 plus the 1, where we have 2. So from here, the dy dx, where we will have 8 over the 3. Try to substitute the situation given in here. If x is equals to 1 over 4, y is equals to 1, and then the dy dx, where we have 8 over the 3. So if we substitute in this part, where we have negative 3 over the 4 y double prime. And then plus, if we substitute the 8 over the 3, then we will have 16 over the 3 minus bracket square 64 over the 9, which is equals to 0. Try to rewrite the situation where we have 3 over 4 y double prime, where we will have 16 over 3 minus 64 over 9. So if we simplify the situation, then we will have negative 16 over the 9 multiply with 4 over the 3. So second derivative, the value would be negative 64 over 27. Hello everyone, in this video I'm going to discuss the example for application of differentiation for the optimization problems. Kindly refers to the question, the total surface area of a right pyramid with a square base of the length x meter is 72 m squared. So refers to the diagram. So here we have the pyramid with the square base. So automatically we have x multiplied with the x. So if we separate into 2, so we will have x over 2, x over 2. So based on the situation given, we have the triangle if we're looking from the side. So with the situation given, we have the right angle triangle and the area which is the 7m squared. Shows that the volume, we have the v meter cube is given by the v squared. So if it refers to the diagram, what we have is v which is equals to x square h over 3. So that is the formula for the pyramid. So if based on the situation, the question said v squared. So we have to square both sides. So we will have x to the power 4, h to the power 2 over the 9. So that is the v squared. Next, what we have to do is to change the term from the h squared become the x. So based on the situation given in the right angle triangle, we notice that we have the y squared which is equals to h squared plus with the x squared over 4. Because we have the squared plus with the squared plus with the squared. Okay, so continue where we have y which is equals to the square root of h squared plus with the x squared over the 4. So if it refers to the area, then we have this surface. Okay, as for the pyramid, we have 4 surfaces. So area, where we have the 4 surface, each surface, we have to make use of the y. So where we have this one as a y. Okay, so we have 1 over 2 because of the triangle, and then x multiplied with the y. Because here, x multiplied with the y. So continue, plus with the x squared because of the base. So here we have the side for 4, and then we have the base. So a, where we have x, we have 2x. So x multiplied with the y, where we have the square root, h squared plus x squared over the 4, plus with the x squared. So if we simplify, 72, which is equals to 2x multiplied with the square root, h squared plus with the x squared over the 4, plus with the x squared. So kindly rearrange the situation. So we have 72 minus, we have the x squared, where we have 2x multiplied with the square root, h squared plus with the x squared over the 4. So if we square both sides, then we will have the situation. So 72, we have 5184 minus 144 x squared and then plus with the x to the power 4 equals to, if we square, then we will have 4x squared multiplied with the h squared plus with the x squared over the 4. So here, after we square both sides. So kindly rearrange the situation so that h squared become the subject. So based on the situation given, we have 4x squared h squared and then plus with the x to the power of 4. So rewrite the situation. We have 5184 minus 144 x squared and then over the 4x squared where we have h squared. So if we simplify, h squared where we have 5184 divided by 4x squared, so we will have 1296 over the x squared minus 144 divided by 4, so we have 36. So that is the h squared. So kindly substitute the situation. So v squared where we have x to the power 4 over the 9 bracket, we have 1296 over x to the power of 2 minus 36. So if we expand the situation, So we have the v squared where we have 144x squared minus we have 4x to the power 4. So we already shown that the situation given. Next, refers to the question, if x vary, find the value of x such that v is maximum and obtain its maximum value. So now move on with the second part. So as for the second part, we have the situation v squared equals to 144x squared minus 4x to the power of 3. So now what we have to do is to differentiate. So if we differentiate with respect to x, so here we have 2v dv dx equals to 288x minus we have 16x to the power of 3. Next, dv dx, which is equals to 0. So if it's a 0, then we have 288x minus 16x to the power of 3 equals to 0. Factor out the 16x, then we will have 18 minus the x to the power of 2. So from here, we have 16x bracket. So we have the situation square root of 18 minus the x multiplied with the square root of 18 plus with the x equals to 0. So x will be equals to 0, x will be equals to square root of 18, x will be equals to negative square root of 18. So by using the first test, we are focusing on this part. So here we have x which is equals to 3 SET2. So by using the first test, we have the interval negative infinity until 3 SET2. 3 SET2 until infinity. For the situation, here let's say we substitute the value 4 and here we have the substitute value 5. So f prime, if we substitute value 4, we have 128. If we substitute 5, then we have negative 560. So this one is increasing, this one is decreasing. So here we will consider as maximum value when x is equals to 3 SET2. Next is to find the volume. So v is equals to 144x squared minus 4x to the power 4. If x is equals to 3 SET2, so the v squared where we have 1296 and then the v where we have 36 meter cube. So that will be the maximum volume for the pyramid. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.